Welcome everybody. Hopefully you can hear me. Okay, so if there is any problem just with the audio, let me know. So I'm Christophe Dumas, the observatory scientist. I'm on behalf of the Scientific Advisory Committee of TMT. I would like to welcome you to the TMT webinar. This is the second edition of this first webinar. We are going to have more throughout the year. The first edition was back a month ago, okay, and it was at a time, convenient time, I would say, for our colleagues in Asia, and this one is more like targeted to North America, but obviously anybody can attend, anybody was registered. So thank you for registering, thank you for your interest in TMT. I would also like to thank the board, or the panel, I would say, for this webinar. So maybe we should go around the table and introduce ourselves. Okay, so why don't we start with Bob? Okay.
Yes, sure. I see that I am listed here as Robert P. Kirshner. That's my name, but you can call me Bob. And I am the Executive Director at TIO.
Thank you, Bob. Feng Chuan?
Feng Chuan Liu, Project Manager. Thank you.
Masayuki?
Hello, I'm Masayuki Akiyama from Tohoku University. Now I'm chairing the Science Advisory Committee of TMT.
Thank you. Tommaso?
I'm Tommaso Treo, professor at UC Los Angeles, and I'm the deputy chair of the Science Advisory Committee.
Thank you. Yuko?
Aloha, everyone. My name is Yuko Kakuzu. I am TIO's education and outreach scientist.
Thank you. Leinani?
Aloha, everyone. I'm Leinani Lozi. I'm the Hawaii Community Outreach Specialist for TMT in Hilo, Hawaii.
All right, thank you very much. Okay, so so this is a panel for this webinar. So feel free to ask questions after the presentation. So that's a plan. First, we are going to go through the agenda that I sent by email. You are free, obviously, to ask any question by chat during the presentations, but we would prefer that you actually ask your questions live, okay, at the end by raising your hands, and we will take them in the order they are received. So I'm going to stop sharing my screen so we can go into the full mode and see everybody. And maybe we can start with Bob with your introduction and welcome.
Yes, thank you. So it's great to see so many of you, even at this kind of remove. So here's the story. I arrived at TIO in May of 2022, but I didn't really arrive. I didn't come here to Pasadena until September. I'm succeeding Ed Stone as the executive director. Nobody can replace Ed, but somebody has to follow him, and that's my job. I'm an astronomer. I was at the University of Michigan for 9 years, and then at Harvard for 31 years. During that time, I did a number of things, but one relevant one was I helped with building the Magellan telescope, the second one. And I've worked scientifically on supernovae and applying them to the problem of cosmic acceleration, and that turned out to be pretty interesting. 6 years ago, I moved to the Gordon and Betty Moore Foundation up in Palo Alto, where I was the head of science. Now, the biggest science project for the Moore Foundation is the TMT. And as those of you who know the history of the project will know, Gordon Moore of Moore's Law and one of the founders of Intel was very interested, has been very interested in adaptive optics and the Keck telescopes. And when he realized there was a possibility of going beyond and building something much bigger, he really helped get the project off the ground, first personally and then through the Moore Foundation. So Caltech and UC, who are two of the members partners in the TMT, have benefited from about $250 million of investment by the Moore Foundation. So that's a great thing. Now, this new job is not easier than the old one. The old one was the easy one because I was giving away the money, and now I have to somehow find it. But you know, sometimes hard things are worth doing. I don't know how many of you had a chance to go to the AAS meeting in Seattle, but there was a really good talk. Well, there are many really good talks, but there was a really good talk by John Mather at the end, which I found very inspiring. And, you know, John Mather, after winning the Nobel Prize, went on to working as project scientist, or anyway, during that time, he was project scientist for JWST. And JWST has been a long, complicated story. In 1996, which by rapid mental calculation was 27 years ago, I was part of the HST and Beyond committee that said, you know, what should we do after the space telescope? And we recommended a big infrared telescope in space. That is a long time ago. And what John Mather emphasized was that some things are worth it. You know, they're hard, they take a long time, but they're important. And so we really should do those things. And I know that TMT is in that category. And so we are going to persevere, and we're going to find a way to build this thing. John also said something kind of interesting. I didn't know, but others do, that he's kind of interested in the ELTs. During his AAS talk, he pointed out the benefits of adaptive optics in the optical, and he has a scheme, kind of a out there scheme for doing that. So that's an example of something that's really hard, but may well be worth the effort. I know that adaptive optics in the infrared is hard. Adaptive optics in the optical, definitely harder. So it does make you think, though, a little bit beyond just the beginning. You know, we're concentrating now on getting started, getting the telescope underway. But the telescope is not just about the first generation of instruments. It's a telescope for the next generation of people. And that's you. It's not me. I'm not going to be using this telescope. And the AAS reminded me of that also. It was the first in-person meeting in quite a long time. It was great to see people. I saw a number of my graduate students. And even more sobering, I saw the graduate students of my graduate students. And if you can believe it, I saw the graduate students of the graduate students of my graduate students, my great-grandchildren, scientifically. So that's really the message. This is not something for the next 5 years. This is something for a generation. And we know it's going to be we're all eager to move forward. It's going to be a long haul. I think John's message of perseverance on important things that are hard, but worth it, was directed right at us. And so I look forward to working with all of you to make this happen. I just wanted to make one little practical matter, which is, it may be an exaggeration, but I feel as if I'm getting organized for a search for project scientists, and we're definitely going to need help from the Science Advisory Committee. So I really will be depending on you for accurate and helpful guidance on that. Okay, so that's my message. I'm really happy to be here and happy to work on this hard job. I know it's uphill, but we're faced in the right direction. Thank you.
Thank you very much, Bob. Okay. All right, so now let's enter in the core of these presentations, and we are going to start with a project update provided by Feng Shuan, the project manager.
Okay, so let's see. How do I turn this to full screen? There's a button somewhere. View.
Yeah, full screen.
Okay.
Actually, this is not the one. You should be in presentation mode or something like that.
Slideshow was the first one under that.
Can you try again? No, that's not the same menu that you had before.
Okay, how about
No. You need to go to the same menu, that pull down menus that you had first time, and that was the first selection.
that? I
No,
don't have
not this one, the one before.
one before. Where's that?
All right,
Okay,
now go to view.
Here, how about this?
Slideshow, so first one.
Slideshow. Okay, sorry about that.
You got it.
Okay, sorry about the delay. Okay, so this is a tax presentation that Yuko and Leilani is gonna help me with our community outreach part of the. So here's the agenda, project status, different parts, followed by community outreach. And for reference, this is a telephone structure and over 2,000, well over 2,000 tons. And this is the responsibility of Mitsubishi Corporation, Electric Corporation in Japan. They have actually conducted past the final design review in 2018. And since then, they've been working on, finishing all the action items from the review and working on production readiness reviews. And next month, and they're going to hold the PRR number 2 and number 3 that captures most of the structures, mirror cell and above, and the site structures and tertiary mirror structures. And so this is a very important a review for them to get ready for fabrication. And in preparation for that, they updated a lot of the, design documentations and the interface control documents. So telescope optics, we're talking about the primary, secondary, tertiary mirrors indicated here. For secondary mirror, the work recently has been for the mirror support system and positioner, and they issued a request for proposal for industrial participation, and we have 6 bids, and the team is actually reviewing this. Hopefully we'll be able to select a proposal and partner with an industry company to start the work soon. Tertiary mirror used to be the responsibility of China, and because of lack of funding workforce in the last 3 years or so, the project team has taken over and to work on the design updates. And since the optical mechanical part of the premium designs almost 4 years ago, they've done a lot of work in advancing the design, completing the design, and getting ready to issue another RFP to seek industry partner within the next year. Both of these M2 and M3 have been identified in the recent NSF PDR as areas that are important, no showstopper, but important enough that we need to advance the work to catch up on the rest of the system. The primary mirror, and recently we have borrowed a optical flat from National Institute of Standards and Technology to make sure our own metrology system has the right optical characters, and this is to make sure that we'll end up with the right radius curvature for the mirror segments. And the mirror segment for primary mirror itself are in production, and in Japan by Coherent Incorporated, in US by Coherent, and Japan and India. We have a total of 62 polished roundels, and this number goes up by 3 or 4 every month. And so this, I want to point out, a few years ago were a major risk because we're counting on multiple countries to do polishing. Now that we do, it's becoming an asset because if necessary, we can move things around to mitigate the risk. So India has invested a lot of funding domestically in their facilities. They have a brand new building, and they bought a lot of equipment, including this 2D profilometer shown here, 2DP, and the coordinated management system they imported from Europe, I believe, and they have signed contract towards the end of importing end-to-end capability for polishing segments. And in fact, the team has come to Coherent a couple of times through training, and each time they were able to polish a roundel. So they're really making really good progress here. M1 segment, we have 492 segments on the mirror and plus 82 spares. For each segment, we have behind it, we have a wafer tree structure that provide tip tilt piston plus 21 degrees of freedom to change the shape of the mirror. And this is a very complex system. We call it SSA. And all of the SSAs are responsibility of India. And so far, they have signed a contract for a fixed price with large industry corporation, Larsen Tubero, for the first 100. and of which the first 10 will be prototypes, and we'll have to make sure they meet the quality requirements, and they have so far produced 2. And the team have really made a lot of progress over the years, even though it's taken quite a bit more time, but this is part of the process. They're taking advantage of the time we have to get ready for this. To make sure that all these hundreds of SSAs meet our requirements when we install them, and we have taken the lesson learned from the Europeans, the EELT, and contracted with the company TNO in the Netherlands to produce 2 of these test setups called SMAP machines, and they are close to finishing the work and ship to us. 1 will go to India and 1 stay in Pasadena for our own purpose. The one control system is spread all over the system. There are a lot of the actuator sensors and electronics behind each segment, but there are also other softwares and control systems throughout the system. So there are a few highlights here. Dustboot is actually a very interesting setup that encapsulate the sensors that face each other. Capacity sensors face each other 2.5 millimeter apart across the edge of segment, neighboring segments, and they have to meet multiple demanding conflicting requirements. One of them is that they have to make sure dust does not get into the sensors during the CO2 cleaning, and we've done such a test recently and passed. And the team also have built 3 of the latest, hopefully the final prototypes called P3 actuators, and we ship to India and will be tested there and at JPL. And before we can ship this, we have to design a shipping container, drop test, and make sure that the actuators survive the ship. In parallel, we actually built a test setup and then testing 10 of the lateral gas flexures, and this is quite important through our earlier work. We understand it's really important to make sure this is tested right and there's no nonlinear behaviors. And we've also done network testing to make sure the latency meets our requirements. Alignment phasing system, this is actually a very important subsystem. It's an instrument sitting on the nascent platform, but its function is to make sure that all the mirror segments 492 perform as a monolithic mirror all the time. And so this is based on CAC experience, and we have active collaboration with CAC, and as you can see in the software and algorithm and everything. And the team is working also on visualization display prototypes. The core part of this APS is algorithm, and this is quite mature. We passed that part of the PDR almost 3 years ago, but the rest of the system PDR is scheduled right now for October 24, and this is actually going to be after the planned NSF FDR. So this is a schedule concern that we're actively working with JPL to try to advance this. The narrow field infrared AO system is the responsibility of this is a facility class AO system, multi-conjugate at first light. Responsibility of Canada NRC, and the system is very mature. The system final design review was held in late 2018, and since then the team has been working in a slower pace, but in the final design update called FDU phase, and they should complete that this year, and that includes a lot more of minor subsystem that has not been to the PDR level. There's a science calibration unit, and they are updating the design requirement documents, interface control documents, system engineering stuff, a lot of electronics design work done. And so that's all making good progress. The real-time controller has been in production in fabrication phase and will have monthly release. So there's work done in Canada as well. The laser guide star facility LGSF has been a responsibility of China, but for the same reason that because they've lack funding and resources and people, so the team in Pasadena project team has taken over in the last 3-4 years working on this with minor support from China, and they had a very successful optomechanical PDR in April 2021, almost 2 years ago, and they're trying to complete the rest of the PDR with a very small team, but working very hard. They should be able to complete that in the next few months. And the work since then have been on a lot of analysis update, requirements, interface controls, software, and electronics. And the concern for, and so we are also applying for NSF funding to support this work. The concern for this work and the tertiary mirror system is that with the work done here over the last few years, it becomes very difficult for China to take it back. Even if funding becomes available, the team comes back. So for first life science instrument, we have the AO-FET, IRIS, MODIS, and seeing limited WFOS. And so IRIS is the workforce diffraction limited IFU imager spectrometer. And this system is very mature, and the PDR was held quite a few years ago. And some of the subsystems FDR final design review have been completed last year, and the team is trying to complete the rest of them this year. And meanwhile, there are a lot of prototype activities going on in UC, at UC and Caltech. And the latest risk is that the Hawaiian 4RG, the 10-micron pitch detector, is becoming obsolescent, and the team is more working on modifying the design to make use of the 15-micron pitch, and that work is going well in collaboration with NLJ. WFOS is the only single limited first light instrument, and this team has gone through about 4 years ago through a major design update, and it's been very well reviewed, and the system is more compact, less complex, and gravity gradient invariant, and better performance. So it's a lot of praises on this, and I think Eric Penn in the audience is project scientist for this. And as part of the review process, and they have finished the conceptual design review for the updated design in about a year ago, and it's very well received. And the team has asked, the review committee asked the team to look at using configurable sleek units instead of the laser cut mask, and that's going well as well. MODIS was the latest addition, first light instrument for exoplanet research, and we felt the first part of the conceptual design review a few months ago, and it went well. But I think the action here is to really make sure we have the right science case, and to justify the polarimetry mode, and make sure we have the right performance budget and requirements to make sure that we actually can build this thing to meet the requirement. And the same from the review committees has been emphasized again and repeated by the NSF review board, and make sure we don't over-design this. So let me change gear to look at the latest the Mauna Kea Stewardship and Oversight Authority that's been formed by the state of Hawaii, and the Act 255 passed in the state. It's off to a good start, and we know the interim chair is John Komeji at the first meeting in November. And he has subsequently said this in multiple cases, including last week at the WS town hall. The authority wants to develop a Hawaii way to address issues, gain from each other trust and aloha, learn to live together. The Mauna is going to be at the center of everything we do, and the mutual stewardship is at the core. And this is a state-level platform to improve the long-term relationship with the Native Hawaiians, to make sure they are at the seat at the table to be involved in the decisions on everything related to Mauna Kea. And with any change like this at the state level, you expect near-term uncertainties, but the long-term prospect justify the short-term uncertainties. They have 5 years to fully stand up, take over, but my understanding is, our understanding is they can take on individual tasks prior to that time. And they are working on this already. And last week, as Bob mentioned, the 3 leaders of this interim authority was the town hall panel discussion moderated by Kaio Kimura, director of Imiloa, and they received a standing ovation. It was really well received unanimously. All the people in the room are highly enthusiastic about this. And the very next day, the Science magazine picked it up. In Hawaii, new state panels, there is hope for TMT. And this is just the list of the people, 11 members, including 1 ex-official, and the leader, John Komeji. This is a summary for the outreach part of this presentation, that the work we're doing are consistent with ISRO 2020, with National Science Board Vision 2030, and for the long-term House of Astronomy in Hawaii, we need to do what's common goods and help the community, help astronomy in general, and hopefully that'll help TMT as well. So that's what we're doing. we're working closely with the community, all community, not just part of the community. So with that, I think we close the presentation. I would say overall, going back to the whole project level, and technically, engineering, science-wise, we're doing very well. We are preparing the final preparation for the second part of the next PDR, focused mostly on cost and schedule. And I think we are working closely with NSF and with the local community, including some representatives, not the members, but some representatives of the authority. And so we're ready to work with them and all aspects that whether the environmental or technical review or the community engagement. So that's the summary, and I'll stop sharing and see if you have any questions.
Thank you very much, Feng Shuan and Leilani and Yuko. Before we take any questions regarding the project update and our engagement, I would like to give the floor to Tommaso, who's going to give some words about the SAC view and also some call for new members. Thank you.
Yeah, thank you. Well, before I begin, I wanted to thank Yuko, Leilani, and Feng Shuan for their beautiful presentation. And I hope one thing remains with you all: the incredible complexity of building such a telescope that requires all sorts of skills and balancing lots of different demands. And in all of this, the contribution of the Science Advisory Committee is to provide scientific advice, because in the end, many of the decisions are driven by science. And the SAC is a representative body. There are 4 members from each partner. And, we work very hard and we do our best, but of course, we cannot know everything, and we are just representatives of the community. And one thing we would like to do, and we've been doing for a time, but of course, due to the pandemic, the engagement with the community has been sort of at a lower level in the past few years. We would like to re-engage the community. And the principal vehicle for that is the International Science Development Teams, also called ISDTs. This is a mechanism that was created about...
Just one sec, Tommaso. Yeah. I don't think you are in the right view. Maybe you want to swap your display.
Am I not? Okay.
We see your next slide.
Okay. Swap display. Is it?
Yeah,
good?
Now it's okay. Thank you.
Sorry, guys. See, it looks like we have never done Zoom before, right? So about 10 years ago, we created this structure, and it's a way for people to contribute to ISDT, and it's a two-way street. So we would like scientists to contribute their ideas and science cases and technical ideas to make the telescope better. And at the same time, we would like to be able to communicate with the community and get their opinion about potential, choices that need to be made, or instrument capabilities, or whatever the community feels. So this is a way to engage the community on multiple levels. And at the moment, we have 9 of these teams covering science fields that go from fundamental physics and cosmology to our solar system, exoplanet, time domain science. I'm not going to read them, but they broadly cover all of astronomy and astrophysics. And we currently have 3 SAC members who serve as ISDT leads: Jan Del Antonio, Manoj Puravankara, and Lei Hao. And they are doing a great job, and they will be coordinating the activities. You may wonder, if you've never been involved in one of the ISDTs, what do the ISDTs do? And here are some examples of what they did in the past. So they were very instrumental in helping us build the previous detailed science case. The document was written between 2014 and 2015, and many of the ISDT members contributed chapters, sections, paragraph, figures that eventually ended up in the science cases. And, it's a beautiful science case that covers the majority of astronomy, demonstrating the breadth of TMT in terms of scientific capabilities. And it would not have been possible to build such an extensive detailed science case without community engagement. And from that science case, you get the flow down to the TMT requirement. As I said, the decisions should be science-driven. And so once we identify the science case, we can write specific requirements for the telescope. For example, a telescope needs to be able to point at this, the sky with this level of precision, or slew from here to there, whatever is the science case drives the requirements that then the project and the technical teams try to meet. Another case in which the ISDTs helped very much was in drafting key projects. So back in 2015, we made a simulated call for proposals. We asked the community to write proposals for key projects that they would write for TMT. And the response was wonderful. We had many, many good ideas submitted as proposals. And I think that really showed the demand and the ambition of the community and the kind of ideas that people can do with an ELT that are not just not possible now. People also participated in the white papers for the development of first decade instrumentation plan. And there were at many levels feedback to many things, like from specific questions from early light instrument teams to other issues. So there's a long history. Of course, the pandemic kind of like put a stop to all this. Prior to the pandemic, we used to meet in person. Here are some pictures from the TMT forums in Kyoto, Mysore, Pasadena, Xiamen. And you can see after 2019, we haven't done that yet, and we haven't been able to return to these in-person things, but we would like to continue and re-engage the ISDTs using Zoom. And I promise I will do better with my PowerPoint slides next time. What's the first step? The first step is to submit an application for ISDT membership. They're due March 1st, and we want this to be absolutely an easy task. So there's no selection, okay? It's not like every scientist that want to contribute to ISDT and it's reasonable scientists should be able to contribute to ISDT. So the membership application is really light, title and abstract. Which ISDT would you like to join? So we can assign you to a group according to your specific interest. And what would you like to do? Okay. And how much time do you think you can spend working on ISDTs? And it can be 5% of your time, 10% of your time. It can be whatever you feel like should be appropriate. And a short CV. Once you have that information, send it via email to isdt@tmt.org. There are more details of the call at the website listed there. And we will evaluate them based on the following criteria: expertise and commitment to carry out work in support of the ISDT's goals and TMT. But I want to stress that this is really like we have no interest in keeping people out. We want all the help we can get. Okay, so if you are excited about TMT, excited about some science that it could be done with TMT, and you have a little time to spend on it, please send us your application. We love to have your contribution, your thoughts, and your ideas. The next thing really high on the horizon for the ISDTs is the detailed science case. The current version of the detailed science case dates back to 2015. Hard to believe. I remember when we were writing this. It's almost a decade ago. Time flies by. You see my hair are grayer than when I wrote this back in I contributed to this back in 2015. There are chapters that mirror the ISDT's composition, not by coincidence, because that's how we organize the work. It was published, and just recently it underwent a minor update for the preliminary design review. The update was really minor in the sense that there was some rephrased introduction and overview and context, some minor updates and corrections of obvious things that were updated. But, it's still fundamentally a document that is almost 10 years old, because we started that project back in 2014, although it was published in 2015. So this needs to be redone. Of course, the landscape has changed. We now have JWST. We have 10 more years of science, so it would be quite sad if science didn't change in 10 years, but it has changed somewhat. Many of the questions remain the same, but some of the answers have changed and new questions have come up. There's also other areas that have boomed since we wrote that case, for example, extreme AO systems and so on. And so there's really a lot of things that have changed, big surveys, Rubin, Roman, and so on and so forth. So it's time to redo it. And we would like to do a major update of the detailed science case in time for the 2024 NSF final design review that, as Fenchuan said, it should be in about 18 months, right, Fenshuan? Yeah. Yeah, so that's kind of like the time scale for us to update the DSC. And so this is the plan, tentatively. We would like to first appoint editors for each of the chapters. And then once we have the ISDT members applications, we will review them and assign, according to scientific interest, people to each chapter, and the editor will coordinate the work on each chapter. And we hope that this will not be a long and exhaustive process. We hope that through the contributions of many, we will be able to do this fairly quickly, and everyone just needs to focus on their specific area of expertise. And your contribution can really be a paragraph, a figure. It doesn't need to be like something more time-consuming than that. And by the summer, we'd like to have some updates combine, and then in the fall we combine all of them, and eventually at the end of the year 2023, the SAC can review and approve the final version to release to the agencies and the public. Now, this is a very important document because, of course, science is the main goal of a telescope, and we want science to be informing our technical decisions and oral decisions. And so the flow down from science requirements is very important. It needs to be kept up to date, current, and fresh. And this is the only way in which we can build a telescope and a set of instruments that does cutting edge science when it's built. So this is this is the part regarding the ISDTs. A comment now on the webinars as a part of this effort to re-engage the community. We will have additional webinars. The second will be focused on first light instruments, IRIS, WFOS, and MODIS. We would like to talk more in detail about their capabilities and science cases. The third one will be, we haven't decided yet, we'll start to focus on a key science field, which could be, for example, exoplanet or whatever. And we would like this choice to be driven in part by ISDT discussions. So it's not that the SAC decides, oh, this is the most important topic. We're going to have a conversation with the community and decide together which topics to tackle first. So this is the plan. We are very happy to hear any ideas, thoughts, and suggestions. Please send them to isdt@tmt.org. And I look forward to working with all of you. I thank you in advance for your participation, and I encourage all of you to submit ISDT applications.
Well, then maybe it's time for me to say again how important it is to have this community support and the communication with you. I've just got here, but I won't be able to say that for very much longer. And so getting to know you and making sure I understand what the interests are in the TMT community is very important. And I really welcome your participation.